Hello, I'm David Greenspan, and I did the original operational transform stuff for Etherpad. I wrote easysync. I wrote a bunch of the code base actually, and currently at Meteor. So you should definitely check out the web framework Meteor, which is hopefully going to make all the other parts of Etherpad trivial, maybe even including the OT when we get there. Um, but it'll help with the transport. It'll help with the UI in the front end. The editor might still be a challenge. But basically, because Etherpad grew out of a web framework in the first place, what we were always trying to do is just kind of push the bar, raise the bar in what's possible in a web application. And we ended up doing that with Etherpad. Etherpad is still a very hard kind of app to write, and hopefully we'll be able to make that easier. So going back in time, this is an email I sent in mid-2008 that I think kicked everything off. We should build a cross between Super Happy Chat, which JD will remember, this is our chat application, and Sabitha Edit. Updates should be propagated instantly using Comet. Merging should be done to an extent that people can comfortably co-edit a document. And perhaps text could be colored by author. There's no current web app like this. Basically, I've looked at the existing ones and they suck. I think there's three hard things about this. There's the synchronization algorithm, the Comet part, and having a browser text editor that has the requisite support for fine-grained updates. All these problems are solved, but also very hard. So basically, there's a lot of room to innovate here. And then I described my scheme for this changeset merging that was basically an all-nighter where I came up with this. So I'm just going to start with the basics of what are change sets and how do you merge them? So suppose our whole document is this string. This is a very nice sentence. Someone comes along and wants it to be, this is a nice sentence. So we can visualize this as crossing off those 5 particular characters. Someone else then comes along and says they want it to be, here is a very nice sentence. So they're going to replace those first 4 characters with different characters. So these are the 2 sentences that they both edited the document into. So intuitively, it seems like these edits don't really conflict. Both authors can have their way. We can have the word here from the first line. We can delete the word very, and we end up with here's a nice sentence on the bottom. So definitely the starting point for this kind of merging of edits or merging of intents would be that if your edits are completely disjoint, you should be able to have the effect of both changes. Okay, what if instead these documents diverge further? So now we have author 2 also modifying the beginning of the sentence. Author 1 now also makes a deletion to the middle of the sentence. So now they've kind of diverged. There isn't any obvious way to reconcile these. So I looked at this and I thought, well, we're not going to make people happy. We're not going to come out with a pristine sentence, basically, that somehow incorporates what both people intended. They're going to have to talk it out. But if all this is happening in real time, if this basically, a couple of seconds go by, why not just preserve what both people wrote, do something deterministic, and then let them, hash it out through other channels, through the chat or through, voice or something. So the basic algorithm is if either person crossed out one of the characters, then cross it out. So you take the union of the crossouts. And then you also keep all the text that everybody inserted. So if someone is typing some characters, presumably those have some importance. We're going to want to talk about those. We shouldn't just delete them. We certainly shouldn't concurrently delete them. You could imagine some scheme where, I type a letter A and someone else does something simultaneously, and that actually results in my A getting deleted. Like, it would be weird for the other person to delete a character they haven't even seen yet. But in some naive formulations of this, that could actually happen. So the algorithm is, cross out all the characters that either person crossed out, keep all the inserted text. In an Etherpad, this would show up as both people get their insertions. The word very is gone, the word nice is gone. So you end up with, here, I like a sentence. And then they have to say, wait a minute, what were we trying to do there? So a change set, which I also sometimes call an edit. You could also call it an operation, which is consistent with the terminology of operational transforms. It deletes some subset of the characters in the input document, and it also inserts new characters at certain positions in the input document. Now let's, to make that precise, we can kind of nail that down more, because what we're looking for is uniqueness of representation. Another way to say this is what change sets are the same and what change sets are different. So one rule is we don't let a change set have two adjacent insertions. We just say really inserting two things adjacently is just one insertion. So in a representation, we'd represent that as one insertion and disallow two consecutive insertions. Another way to say that is just that there's only one change set here, even though we've written it two different ways. Second point is deletions before insertions. So it's kind of similar what's going on here. These insertions are consecutive in the output document. Basically, the document said world. Someone deleted the entire, it said world exclamation point, sorry. Someone deleted the entire word world, and they put in the word there. So really, it doesn't make sense to have these different insertions that are kind of floating in between the deleted characters, because those deleted characters go away, and we're just left with a word. So a way to put that as a constraint in a unique representation is to say, if you've got some string of insertions and deletions, put all the deletions first and all the insertions at the end. So that it's only one way to write that change. On the other hand, no ops are okay. It's okay to have a change set that deletes a character and replaces it with the same character, or deletes a word and replaces it with the same word, because someone actually took the trouble to highlight that word and retype it, for example. One way to say this is that it captures the intent. There's this term in the research literature of intention preservation. And usually in practice, all that means is, stuff like an insert should still be an insert, and it should still be kind of in the same place in the document, conceptually speaking, even if the text has been shifting around concurrently. So this is actually, I remember when Wave first came out, and I kind of was looking at the Wave source code in my console, and I was reading the mailing lists, and I saw that it actually is legal to, delete a character and insert the same character. And it's like, aha, they've been doing some thinking about this. They've got real operational transforms here, I think. So yeah, another way to say that is that these are different operations, and there's an infinite number of ways to bring a document back to the same state, and they merge differently, basically, or they transform differently. So interesting property about change sets as I've described them is that they compose in the mathematical sense, meaning for all change sets A and B, there's a third change set C that has the same effect of applying A and then B. So in a diagram, if you can get from one state of the document to another via a change set, and then into a third state via another change set, then there always exists a single change set that kind of takes you the whole way. It's kind of like a single diff, basically. We can also merge change sets. So I already described how, roughly you might merge two people's simultaneous edits to a document. The way we express that is to say, for all change sets A and B, we can define some change set C as the merged change set that's supposed to have the same effect as if both were applied at once. Actually, let's skip to the diagram. So this is just, it fits on the screen better if I use a word instead of a sentence. These changes won't be very realistic because usually people don't edit the word hello into the word yellow, but it's easier to draw that way. So one person takes hello and adds an exclamation point. Editor B on their own computer changes a couple of the letters and turns it into yellow. And wouldn't it be nice if we could both come up with the merged document in the lower right and this single change set that somehow does both at once? It adds the exclamation point at the end, and it inserts this W and changes the H to a Y. And the rules for doing that, which are basically what I described earlier, are that diagonal line, that merge change set, has to keep only characters that are kept by both A and B. which another way to say that is it deletes the union of deletions. It deletes everything deleted by A and everything deleted by B. And it performs all the insertions of A and all the insertions of B. And then to nail that down more specifically, we have to worry about this rule that deletions always come before insertions. And there's also the subtlety that two people can insert text in the same place, and you have to order it one way or the other, basically. And this could be that it only ends up being in the same place. So we have to deal with all these crazy scenarios, basically. Like, imagine one person in an Etherpad deletes the whole first half of the document and makes a bunch of edits to the second half. The other person deletes the whole second half of the document and makes a bunch of edits to the first half. There's no good way to resolve this, but in practice, the way it will be resolved is basically all the old text is gone and all the insertions from both people are just kind of laid out back to back, which is like, you know, guaranteed to look weird, but it's also guaranteed to work. So the way you decide how to order those inserts is basically they're anchored by the position they were inserted into the original document. And if two people literally started typing at exactly the same place, then there's this like tiebreaker that happens. That's basically, you know, if you have editor A and editor B, editor A wins and their text comes first. And that introduces some kind of symmetry breaking into the algorithm, but it's necessary. So if you implement that, then you have this, you can basically take those two arrows, the top one and the left one as input, and generate this diagonal arrow as output. But wouldn't it be better if instead you could generate these arrows? So these arrows are, okay, I've already applied change set A, now I've got change set B, what do I do with that? Or I've already applied change set B, and now how do I apply change set A? So really what these change sets are the transformations of the original change set. The way to think about transforming an operation is you're taking the arrow on the left and you're generating the arrow on the right. Or you're taking the arrow at the top and generating the arrow at the bottom. And I put this in my head as you're transforming one operation against another. You're transforming it so that it allows for this other operation to have already happened. So if we could generate those arrows, then we could basically do anything. And we can reach the document states by applying the arrows to their source document. I think an interesting thing about this diagram is that all 5 of those change sets are completely different. It doesn't even make any sense to apply one of those arrows to a different document that the arrow doesn't originate at in the diagram. And you can also tell that there's going to be, something has to happen to interrelate all 5 of these. So how do we do transformation? I tried to condense this into something that I can say in one slide that should be roughly understandable, maybe even implementable. So you have A and B, which are both applicable to the starting document. So basically, actually, the prerequisite is you have these 2 arrows that both come from the same document, so the one going right and the one going down. And the output will be an arrow that starts from the output document of one of those. So kind of I always go back to this diagram just to figure out like which arrow I'm making at any given time. So the goal is to transform A. You want to compute an A prime such that it makes sense to apply B and then A prime. The way to do this is, like one way to think of this is you've got your change set A, but wait, B has happened before that. So I'm going to have to skip some extra characters that are kind of intermingled in the input document, which are inserted by B. I'm also going to have to make fewer deletions, because it could be that this other change set B came along and already deleted everything I was going to delete. Or it could be that, deleted nothing and now I have to make all the same deletions. So you can think of the transformed operation that you're trying to generate, A prime, operating on a document of characters that either B kept or B inserted. If you're looking at the document that the operation spit out, all those characters were either kept or inserted by B. So you want to keep everything that be inserted, and then among the things that be kept, you want to delete some of them, which are, basically the ones that A had to delete that weren't already deleted. So I don't know if that made perfect sense, but basically, if you think about what's happening, you can kind of work out from that description how it should work. Concretely, a change set in all the ways I've ever represented it in code is a list of spans of text that are either inserted, deleted, or kept in the course of applying the change set. And these are spans of some number of characters, and there's various constraints of the kind I described. The functions you need to implement are: how do you apply change set to a string? How do you compose change sets A and B? And how do you transform change set A against change set B? And the way these implementations look generally is kind of like a zipper algorithm, which is an algorithm that takes two streams, so streams of spans of text in this case. So, your change set might say, now insert a Y, and now keep 4 letters, and now insert a W. Your change set basically breaks down to this linear sequence of operations. If you have 2 of those, and what you're trying to spit out is also a linear sequence of operations, the way you do this is basically you have 2 pointers, the way you might in a string comparison algorithm. But it's a lot more complicated than a string comparison algorithm because each pointer points to one of 3 different kinds of things. So, say you see 2 inserts, and that means you have to decide which one comes first. Or you have an insertion and a deletion, and then you have to reconcile them and figure out what you're going to emit into your output stream. So that's the general form that these take. So easysync basically implements these operations on a particular string representation. How is easysync used? In Etherpad, it's used on the server in order to transform edits to apply to the latest revision. So what this means is the client can say, make these changes relative to revision 5. And the server says, oh crap, I'm at revision 8, what do I do? And the answer is it takes these intervening transformations intervening change sets that produce revisions 6, 7, and 8, and it transforms the new change set across those. On the client, transforms are used to apply remote edits that come from other users to the current state of the document. In some OT using applications, you can get around this part, but basically what you have to do is you have to rewind the client and replay it. Like if you're in some sort of graphics editing PowerPointy like application, and some change comes in from the server, and you've made a bunch of changes on the client, sometimes what you can do is use something like the undo stack and roll back all of your changes, apply the server change, and then roll forward and kind of compensate as you go. Like if I've deleted an object that was also deleted on the server, then, oh, it's not there. Don't throw an error, just move on. What using OT on the client lets you do is to basically filter the changes coming in from the server through the changes that have been made locally. So if I've done a bunch of typing, the client-side code has looked at that typing. Maybe it's turned it into a change set, but it hasn't even sent it to the server yet. So there's this kind of diff or change set that applies between what's represented in kind of the official version of the document, and then this kind of overlay of what I've been typing. If a change comes in from the server, it can transform that change across this overlay, across the changes I've made locally, and figure out literally just what character to go in and change in the editor. So that's very useful. It's also used in Etherpad's undo redo. We have a infinite undo, and you can undo your own changes even if changes have been coming in from the server in the meantime. So like concretely, if I left Etherpad open, I've made a bunch of changes, I'm done, I step away from the computer, and suddenly someone else does a bunch of stuff, I still have my entire undo stack. I can do undo, 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 and go back in time. And it just kind of goes around the other people's edits. And the way that works is this is basically another application of the same OT, which I don't have time to describe here, but it's kind of cool. It's basically like the operational transforms kind of point backwards in time along the undo stack, and the other people's edits are kind of like are transformations you have to change against, transform against. So it's this whole different formulation of this like OT undo stack that actually works out really nicely. Okay, so easysync. One of the goals of my presentation here was to actually talk not just about the theory, but about what it looks like in Etherpad after, a couple years of working on this. So this is the string representation of transforms. It's very cryptic. I'll come right out and say that. I designed it to be very compact and use as few bytes as possible, basically. It starts with a magic string, which is a capital letter Z. All of these numbers and letters are, I think, base 36 encoded, and that was just to save the extra character once in a while. It starts with just kind of a sanity check of, do you have a pointer or something? You can just point at the screen. It starts with a sanity check of the length of the original input document, and then the delta to the length, which is either greater than or less than, and then how many characters greater than or less than the output length should be. And because as soon as you generate a change set, there's only one document you should ever be applying that change set to. So this is kind of like just to make sure it's being applied to the document it's supposed to be. There's then a series of operations where equals n means keep n characters, plus n means insert n characters, and minus n means delete n characters. Any characters that are supposed to be inserted are pulled from this string at the end. So everything between the dollar signs at the end is just this kind of buffer that, if you say insert one character in the course of a change set, it pulls the first character off of the buffer and uses that. And I'll explain these. I'll explain the pipes and the stars in a second. Oh, yeah, so stars. You see, there's these stars, like it says star 1 plus 4. What that means is this is our representation for rich text, basically, which was totally hacked on top of the plain text representation. It's that every document character has a dictionary of string properties. Inserted characters come with a dictionary, and kept characters have a dictionary of sets and deletes. So when a character comes into being through an insert, it could say bold true, or it could say nothing and be plain text. When you keep an existing character, you could remove the bold attribute or add it or set it to something different. And in the implementation, the way you remove something is basically setting it to the empty string. So to make this really, really compact, there's this concept of attribute key value pairs are basically kept in a pool and identified by number. So star 1 might mean set to bold, and star 2 might mean unset the bold property. And the way this is implemented is there's this kind of global pool of attributes where 1 maps to bold comma true and 2 maps to bold comma empty string. So these pools of attributes you may have seen in the source code, and in practice you end up having to sometimes port a string from one pool of attributes to another and do various operations on attribute pools. But the payoff is that your representation is really compact. You don't have bold colon true listed 100 times in your document. Another thing that was added later is line hints. So often you want to apply a change set to a data structure that already has it's already broken into lines. It's either the DOM or it's some data structure like an array of strings. And it turned out to really suck to have to say, at character 1334, insert the letter E. So what we did to kind of bolt this on to the existing representation was there are these pipe characters, which are kind of also like a modifier that comes before an opcode. And it basically, I think it just says how many new lines are in the string. either the string that's inserted or the string that's skipped over. So if you're clever, you can use that information, and easysync has an implementation of this too, use that information to kind of skip through a data structure faster. Oh, and that's right, the way it also works is these multi-line spans have to end in a new line. So if you want to go to somewhere in the middle of the third line, you have to say keep 2 lines and then keep 34 characters and then insert a character. And then bullet lists, which are a total hack. The line starts with a hidden asterisk that you never see in the editor, and the properties on this asterisk define the properties of the list, including whether it's a number or a bullet and what level it is. I'll say one thing that's really nice about this is that unlike HTML, where you have to make nested lists by having a UL with an LI, which has some inline text, and then a UL, if you say every line of a list just has its own list level, it makes it very easy to do indent and outdent. Like, you know, you can be in the middle of a list and tab, tab, tab to like move your bullet in, shift tab to move it out. Whereas the manipulations to the underlying HTML, say if HTML were your representation, would actually be really like tortured and hard and non-local. So definitely like that aspect. On the other hand, doesn't. No. So why is it so cryptic and compact? I made a slide about this. Basically came out of my extreme concern about the size in bytes. What's it going to look like in SQL? It needs to have some serialization, obviously. A single change set, say, and you're going to have thousands of these in a pad. In server memory, so we were using Rhino on the server, which is JavaScript interpreted by Java or compiled to Java. So, you know, even an object like x:0, if you draw out what that boils down to in the heap, it's actually really big. It might be, you know, 300 bytes and involve 5 or 6 objects. There's like the string x, and there's the number 0, and there's like the hash map that represents the properties of the scriptable object. So I was really concerned that, you know, if we had a choice between a 20-byte string and like a 300-byte data structure, you know, we should choose the compact string. Then it goes on the wire, and then in the browser, you also, you know, could end up with a lot of objects. The JSON could take a long time to parse. Things have gotten better. Actually, now we have JSON.parse, and modern browsers are extremely fast at parsing JSON. But, you know, looking at IE6 and 7 and doing actual like speed tests with different implementations, we found that it's sucky to generate a lot of objects. And Wave actually took a lot of time parsing JSON and then walking the resulting data structures. Also, string operations are fast in JavaScript. Slicing strings, concatenating strings has been heavily optimized. And maybe you end up with a lot of, you know, one-character strings in the process of crunching these things, but at least you avoid zillions of tiny objects. Looking forward, though, if I were to do it again, I think gzipped JSON on the wire. So first of all, I think there's a way to have the representation be JSON and be a compact format, and maybe with some shorthand and some things like the attribute pooling to keep it short. But I think you could have it be JSON, which gzips well on the wire, and browsers parse faster now. Another approach you could take is to say we're just gonna specify a change set as an abstract data type or as an interface, and not representation. And then we could have different representations. There could be a JSON one, a string one, and they'd all be precisely specified. Another idea would be to have variant representations. Like if you look at this, you see that after a certain point, it just starts being like insert 3 characters, insert 2 characters, insert 4 characters. So even if you had a rich JSON representation of a change set, you could still have a shorthand form that's just like insert this string at this position, and then you know you're going to get even just one of those 2 forms in your database. I also like the idea of, since we ended up having data structures that had lines in them so often, just say a document representation. Like a document is an array of lines, and each of those lines has certain text that can be operated on. and lines can come and go. I haven't actually tried to implement this, so I don't know if it comes out nicely, but and then instead of lines, you could actually have paragraphs, headings, list items, all be kind of like top-level objects, and have operations for inserting and removing them. Plus side to this is that it'd be a lot more... Well, first of all, it would let you do stuff like list items in a reasonable way. And second of all, it would lead to kind of pretty direct, efficient representations of like changing something in the middle of a long document, which started off being you had to find the character offset, and then we made it a little better because you actually had the information of how many lines to skip to get there. But I think you could go all the way and just say, this line is mutating, line 34 should have this operation applied to it or something like that. And it also might give you more tools for tracking how text changes, or kind of a more diff-like conception of lines. I don't know. More even higher level ideas, make all change sets invertible. So actually record the text that's deleted. In Etherpad, you can invert a change set, but you have to have the input document and the change set, and then you can do this invert operation. And to implement the time slider, what we had to do was we wanted to send down all the forwards and backwards operations to the client. So we had this background process on the server that would take all the change sets in a pad, like all 50,000 change sets, and calculate their inverses and then cache them in RAM. And really, it would be nicer if you could just take a change set and invert it, and that would be a well-defined operation. What that would require is just having the information basically of what attributes were deleted or changed and what characters were deleted. And then you could do that. And I know other people implementing Etherpad like OT have actually done that. I think you should probably avoid ever processing thousands of change sets. This was most useful for fine-grained history. What you could do there is either collapse the history together or just, always deal with the working set of changes. In practice, you don't have that many changes in flight in any given time, and the OT is really only used to resolve stuff that's happening in line. It doesn't work well for long offline sets of changes anyway, where you need real human conflict resolution. So you could just say, let's keep 30 seconds of change sets, and the rest is history. Literally. I think it'd be nice to decouple the text editor. And then my next point is hardest part. Yeah, so there's two hardest parts, actually. One hardest part is the rich text editor, which I feel like there's still room for something better than what's out there today. Etherpad's editor actually still kind of holds up in its feature set and kind of reliability and cross-browserness, and the API to it that lets you make arbitrary changes while someone's typing. So that's definitely a hard part, and I think there's room there to decouple it more from the OT and the representation. Like, what does the interface with the editor have to be? And then the other hardest part is the document representation, and that's hard in a different way. That's just hard in that, there is no rich text representation, really. We're not going to base this on RTF, and have that in the back end. Why not? I considered it for about 20 minutes, and I pulled up the spec. And I flipped to page 171 and saw something about, third column of table should be centered as some sort of \escape tag. And I was like, I don't think HTML makes a very good in-database representation. So really text with attributes or a wave-used XML, use kind of a hybrid of XML and annotations that were stored separately and applied to some range of the XML. And I think it's just a legitimately hard problem. What is a document representation that works well? And people come up with their own. If you've used Quora, they have their own. I think internally, something called QText or something. That's how they store rich text, and it supports the 8 rich text features that they support. Huh? Yeah, it's JSON based. Probably, yeah. But it says things like, and now there's a horizontal rule, and now this text is bold, and this text is italics, and stuff like that. And once you've got that, then it's just a matter of applying OT to it. And these are just general principles. On the one hand, there's no single way to do OT. There isn't going to be one, OT format. There's no monopoly on OT. On the other hand, it's not something a lot of people know how to implement or have implemented. So I definitely look forward to there being more stuff like this out there. Thank you. Any questions? Yes.
How much of the OT literature do you read when figuring this out?
So as soon as I realized it was OT, which was kind of a few days later, I read everything I could find, and I didn't find a lot. And actually, it would be nice just to have a paper to point people to, actually. And it's hard to even find that. The prototypical paper in my mind restricts itself to, let's take inserting one character at one position as our operation and see what falls out of that. And then says, suppose we have n clients all talking to each other through noisy channels. And then the really advanced papers will say, what if messages are allowed to be reordered in transit? So you, at the OT level, have to account for stuff being reordered. And what we found for actually implementing this is that you can really simplify the OT level a lot by having a centralized server saying there's a canonical history. All you have to negotiate is each client with the central server, not clients with each other. You don't need vector clocks. You don't need that stuff. And I never found something that really told that story. Or even had something really fundamental and compelling as a motivation for an OT scheme or some different OT scheme. Except for the commutative, what do they call it? Commutative data types? Commutative. Those kind of are in an interesting parallel universe to OT where, yeah, CDRT, yeah. I recently figured out how those relate to OT. They're actually, it's a different universe where instead of ever doing transformation, you just have a way to refer to all the characters in the document. So if my document's hello, each of those 5 characters has this permanent identity. And at any point in the entire future of the universe, I can say, insert something after that E or delete that E. But then in practice, the way you have to implement this is you generate these identifiers using some sort of binary tree or something. You get these long lexical identifiers. And then at some point you do a rebalancing where you basically say, okay, I'm just going to rename all these characters to shorter identifiers based on a balanced binary tree. And when I realized that that's actually OT at that point, it's basically saying we're not going to do operational transforms at every step. What we're going to do is have some period where you can still refer back to any character by a unique name. And then at some point we're going to do this renaming, which basically amounts to the transformation. But usually what they say in these papers is, we'll just do the renaming periodically every few days when nobody's using the system or something. Well, when there's no outstanding operations, basically. But in theory, you could do rewriting and then you basically have OT. So I think people sometimes are attracted to that stuff instead of OT because OT just seems harder and more complicated. I think they both have their complexities, and I think this probably ends up looking better on the wire. I don't know. Yes?
You kind of roll some of your OT stuff into media?
Sorry?
So you're working on media, right?
Yeah.
Yeah, so you're going to use OT stuff in media at some point?
Yeah, I think so. We're kind of getting as much mileage as we can out of a non-OT world right now, but I think there's going to be a way to put OT on top of it. Yeah, definitely. Or it could be that the OT is kind of a feature of the data store. There's different levels you could do with that. OT for pixels?
Yeah. Or audio samples.
Yeah, you can apply these principles to any type of data structure. And in fact, they're a lot easier to apply to something like the PowerPoint type app I mentioned, because all you're doing is, setting properties on objects, and those objects have an identity. It's really the fact that characters in documents don't have, persistent unique IDs that makes this stuff so difficult. But yeah, it's exciting. And I think, a lot of stuff's going to have to be done this way to reach that real-time collaborative level. And maybe that's going to happen. Maybe everything's going to be instantly real-time. I don't know. Sometime around the time when everything's on the web and there are no desktop apps anymore, everything will be OT. Yes?
When you guys implemented this in Etherpad, what was the latest state? Like, you had any plans, or like you had really bad bugs, or was everything perfectly working as you planned it at this point? Because some sort of picked it up, and you're not sure, like, you found a code that looked like it was, like, you planned something, but you never realized it.
You mean plans at the, at the product level? Or?
Yeah, like, when it was bought by Google, like, how was it? Like, was it stable, or would you say, like, stable?
It had reached a point where different adaptations of the product were going to require different features. We had some plans. We didn't have plans that involved us getting millions of dollars in revenue, which was, one problem. But like we had plans. So there are different directions to take the product. One is kind of a wiki where you have really good support for making offline changes, getting emails with batches of changes and stuff like that. Another was to make it good for programmers, bring syntax highlighting back, which we actually cut at one point to kind of clean up the code. Yeah.
You can still make two spaces and then press enter and keep saving them.
No, but I mean actual highlighting.
Yeah, originally we had syntax highlighting.
Tell them how you implemented it.
What?
Tell them how you implemented it.
What?
At some point, we were considering, and David did a bunch of work to try to do this, although we didn't end up shipping it, of actually using the TextMates like, plugin bundles inside of Etherpad.
Yeah, so TextMate has this cool way to specify modes where, basically regular expressions say when to enter or leave a mode, and you've got this like stack of nested contexts and scopes, and you can have an HTML document with a script tag, and it'll go into JavaScript mode and all this stuff. And I thought, what if we could parse this and basically use it or compile it into JavaScript? One of the big obstacles was that Ruby regular expressions and JavaScript regular expressions are not the same. So I actually wrote code to parse their JavaScript regular expressions. Parse their Ruby regular expressions. If they used a look behind where JavaScript only has look aheads, then it would do some complicated rewriting that was efficient in most cases, but might duplicate a bunch of stuff.
How many years of your life does that work?
So I took like 2 weeks, and it actually worked, but it was really, really, really slow. And it spit out like, 200K of JavaScript for like a mode. Yeah, that was written in Scala, actually. But yeah, originally it had JavaScript syntax highlighting, which was ported from Pigments, and it worked. It was incremental, so it would like kind of be scanning through the whole document in the background and updating it as you typed and without interfering with you. We cut it because it was just, there's a real product decision, right? Like there's this whole mass of people who just don't care about syntax highlighting. They're not programmers. And then there's people who are programmers, and like when you're programming, you don't care about rich text. You don't make parts of your program bold or italics and expect it to, stick around. So we basically went in the more mainstream direction. But there's still a question of like, is this for meetings? Is this for, is this an enterprise wiki? Is it for screenwriters or school teachers or lawyers? Maybe it should have really good, like, Word format, import, export, right? There were lawyers who were saying like, everybody would use this if it would just let us import our legal Word documents and put them on the projector and still preserve like signature lines. And here's what we need. We need like, like borders on tables to work, and we need, paragraph spacing and line spacing to work the way it does in Word. And so there are kind of all these different directions to go in. And we were at a point where what we had was pretty mature in some ways, but, you know, yeah, just hadn't been taken in one of those directions.
Right. I think we were at the point where we were realizing that if we wanted to keep going and make a lot of money doing it, that we would need to specialize in at least one or two different ways. So I think what you're saying, correct me if I'm wrong, but I think what you're seeing is sort of probably what would have been the last fully generalized version of Etherpad when we actually open sourced it. That feels that way.
Yeah, I mean, it was at the point where we'd have to pitch VCs, and that just really switches your thinking away from like, how do I implement, you know, dragging images into a pad and having it work, to like, what's the bigger story here?
Yeah,
Yeah.
people ask me, like, yeah, we want images and we want tables and we want videos. They're like, we just have back to much easier. But 3D characters.
So Wave proved to me that it's all possible, because we came to Wave and they had like images and you could like, you know, edit the caption of the image, and it was like kind of a editable area inside the editable area, and I was like, I didn't even know that was possible. But apparently it's all possible. You can have, you know, widgets that aren't editable inside your editable document. And so, I mean, and browsers have only gotten better in dealing with content editable, but not in mobile. So there's still this like weird question of,
I was not dealing with it.
huh?
I was not dealing with it.
Wait, you can have content editable?
I'm going to show it in my demo.
Android
Cool.
4 and iOS 5, I think they all support it.
Cool, cool.
Yeah, that was a big relief. People are boring all the time. We want to work with mobile. You can't do anything.
Because
I
it's
mean,
kind
it's still hella buggy. Don't get me wrong.
It is content editable.
Yeah, I'm pretty sure buggy is part of the design for content editable. It was in the Microsoft original spec, must be buggy.
I know the guy that wrote a W3C spec for it, and he devoted 7 pages to watch his browser do when you
Yes, yes. So things that happen in browsers when you press enter include inserting a BR unless you're in a block element, in which case you break the block element. Always inserting a, you know, closed paragraph, open paragraph. I think Internet Explorer goes and like turns a bunch of surrounding things into paragraphs. I don't know. Oh, it's also different if you're on a blank line, or if you're on a blank line like followed by a blank line, or if you're at the beginning of the document or the end of the document. Originally in Firefox, you could actually like arrow key kind of out of the document, where you had this kind of like 3-pixel high insertion point at the very top that was like technically outside the body of the document or something.
Oh, that maybe explains it.
Yeah, thankfully most of those bugs have been fixed in Firefox and Safari and stuff. All right, I'm over time, so come see me later.